Hello and welcome to this video on the cabinet control box. Today we'll explore how this control box operates, including its connection, functionality in manual and automatic modes, and the roles of relay. We will also demonstrate how to complete a circuit using 24 VDC, discussing syncing and sourcing configuration, and explaining why 24 VDC is preferred. Let's get started. So the overview of the control box. Uh, the cabinet is designed to control and protect a three-phase motor. Here's a quick look at the key components. First, we have the power supply using including both 24 VDC relay and 220 VAC to manage the voltage and circuit. And the control feature is equipped with a manual selector switch, start stop button, and an inverter to control the motor speed. A safety mechanism featuring a circuit breaker, an emergency stop button, and thermal relay is called overload to prevent overload and ensure safe operation. And the output is to control a three-phase motor for feeding and discharging operation. Okay, so let's see how the relay work. For the relay are the backbone of the cabinet control system. Here's how they work. First, they have a coil which energized by the control circuit. In this case is 24 VDC. There are two contacts switch between open, normally closed, and normally open state to control the motor skip. How do they work? When the relay coil is energized, in this case if the circuit is complete, the contact switch either completing or breaking a circuit. Okay, so today we'll show you how to wire relay. So the bottom one, so this is the relay diagram. So the bottom one is going to be 13 and 14. So it is the sourcing for the relay. In this relay it's 24 VDC, so you have to wire 24 VDC into the port 14 and 0 VDC into the port 13 to complete the circuit. And we will have the port number 9 and number 5, which I'm going to show you where it is. So as the number 9 is where I pointed right now, is going to connect the number 5, which is 5 and 9 is going to be normally open circuit. And if you wire number 9 and number 1, it is going to be normally closed circuit. So if you want to look better how to wire relay, you can just look at this diagram. So it works as the same for the other sides as well. So you can choose whether do you want to wire normally open or normally closed. So that's it for the relay. So I'm going to try to connect and complete all the circuit for and going to show you how to. For an example, if the relay is turned off, the light will be off too. So when we plug in this plug right here, the relay will engage and the NC switch will switch to it usually when the lights turn off, when the relay turn on. So if the relay turn off, the switch will switch to normally open, and if the light turn on, the normally open is going to be normally closed. So that is the relay. Okay, so and there is a self-horn feature which I will uh, explain to you in a second. Okay, so the self-horn feature is actually located in this relay. So some of you are not going to understand how this diagram works. I will show you the real one in a few minutes. So how the self-hold feature works. When the relay is energized, a feedback loop keeps the relay coil powered even after you release the start button. So how to shut them off? Pressing the stop button breaks this loop, de-energizing the relay and stopping the motor. And we'll show you how to complete the circuit. Okay, to complete the circuit with a 24 VDC power supply, a power supply connection is to 24 VDC is the positive connection and 0 VDC is actually a negative connection, or you can call neutral. So to see if this circuit, I mean this control block is actually sinking or sourcing. So sourcing is a positive logic. The control device is provided with a 24 VDC to the load, completing the circuit to the ground. So, and in the contrary, syncing is like the control device is connected to the load, to the ground, completing the circuit from a positive source. Positive source. So, what is this control block? Is actually this control box is actually using a sourcing configuration. So why? So this control box is actually how can I write? Actually supply. Okay, so first mention. We actually supply with 24 VDC and actually complete the circuit with 0 VDC like that. So sourcing is actually safer. Why? Sourcing is safer and more reliable, especially for industrial environments where standardization and compatibility with sensor are essential. So that's it for the sourcing. So if you don't know what the sourcing is, okay, so how do you know syncing and sourcing? This diagram actually show how syncing and sourcing is. So the sourcing is when the device source the load with the currents and the load complete the circuit to the ground. And syncing, what is syncing actually is? Syncing is when the load is sourcing for the device, the current flow into the device that cause syncing. So now you know how to wire your control box. Whether if your load is sourcing or syncing, you can now wire the device according to the syncing and sourcing modules. Okay, so that's it for the slide. Okay, so once I turn the breaker on, so you can see that the relay can be started. So we can see if we can start the circuit or not. So we have select the mode to none, so you cannot start anything. So if we select the mode to manual, you can see that you can start also because the relay is not turned on by the sun off. So if we push sun off, the relay is actually turned on, and now you can start it. Push start button. Okay, so push start, the magnetic is going to start, but this is not going to be the self hold yet. We just put to start and release to stop. So we are going to see how to wire self hold in the next few minutes. So next we are going to see if that how the trip is going to work. So if we trip, you can see that all the circuit is going to shut off and the yellow lamp is going to turn on with the lamp. So after the relay, no, I mean after the magnetic is acknowledge. We can now restart the process, and let's see if we can just push start. Okay, so okay, no, I mean, in this we are going to push the emergency button first. So let's see. Okay, so if we release the emergency button is going to uh, restart the circuit just like a trip mode. So we are going to try to do self hold next. So this is the self hold that I have already added two wires to the relay, and it is waiting for the supply. The supply is currently uh, wired as a normally open circuit. So if the relay is turned on, so when we push the start button, we don't have to hold it anymore. It is going to run until we push the red button. So that is for the cell phone. It's going to be the auto mode. So the auto is going to connect the floater at the terminal 18, 19, and 20. This is the common line. It is going to be waiting at the select manual, select auto mode. And select auto mode is actually supplied from the relay. So when the knob is turned on, the relay will have the supply, and the supply will feed to the common of the floater, and the floater is going to send the uh, VDC to the select feed or discharge, and it is currently jumped because the feed or discharge is going to send one data to the relay, and the relay is going to start the motor if the feed or discharge is selected and the floater is doing its jobs. So the next one is going to be the inverter SD and STF. So you can see that if the SD and STF is actually connected to each other, the inverter will be started. Okay, now we are going to run full steam. So first we select to the manual mode, and we don't put the knobs. Can we start? No, we can. So if we put the show knob, we can now push the start button, and the inverter actually start too. So let's see if we put the inverter button. So the circuit of the control box is actually cut off from the power, and we start the process, and we can now put the start button again. And if we put the skip button, we can see that the orange lamp is on, and the circuit is completely cut out, and we push the acknowledge button. So this is manual mode. So now we can do the auto mode now. So the auto is going to be the same as the manual mode, and now we put to the auto mode. We can select between feed and discharge. If the floater is hanging down, the magnetic is going to start. If the floater is hanging up, the magnetic is going to stop working. So this is the manual mode. And flip button is actually placed. So in this, the flip button is placed, filter is not working, and the, we have to reset the circuit as same as the manual mode. So we can see that if we put the inverter button, the cabinet is going to stop too. So this is the hardwiring of the cabinet control box. So this is it. Okay, so we have come to an end of this video. So in conclusion, the cabinet is a versatile control box offering safety, reliability, and adaptability. From manual to automatic modes, relays, self-hold features, and sourcing configuration to ensure smooth operation. The use of 24 VDC enhances safety and compatibility, Thank you for watching. If you have any question or want to see more tutorial, feel free to reach out. Thank you.